Project 1, right?
Correct.
Yeah, okay. Now I just gone through the HDFS one. I started. No, I did not start with the practical, but I just had an overview of it, what it needs to be done. I think
Okay.
creating directory and
That is
uploading
for
the field.
completely HDFS command.
Yes.
Okay, fine. I believe my screen is visible.
Yes.
Okay. What we discussed in Hive as of now, type of tables. Just I will give a quick overview. Type of tables with internal and external, and internal means managed tables. Managed tables, and then external tables, and then temporary tables. Temporary tables. And while creating the table, we see tables with location that will be in the external table itself. External tables with location and without location. Without location. So difference between with location and without location is only that if with location, no need to load the data or file. Automatically to the location, whatever files are available, that will be available in your table as well. With the table schema, you can query the data. Without location means you have to load the data either via table or with file, your source file. Then we discussed about partitions. And in partitions we discussed about dynamic static partitions and then dynamic partitions. Static partitions mean simply partitions means we are providing a layer of optimization in the table. So if we are going to deal with good amount of data, then table will not be scanning the entire data set, because as a data engineer or you anyway, either you are working for data side with any name, you can say either data science, data engineering and all. There you are going to work with huge amount of data. In that condition, if you are not caring about that, and you have to do some analysis kind of work, then you are going to scan entire data set, and your data can be in GB, TB or PB. It's not a good exercise to scan the entire data. Then let's break the data and scan whatever is needed. In that case, you can go for the partition. Partition will be segregating the data automatically. Automatic part will be happening in the dynamic side. Static means it is kind of manual intervention from our side. And here, if you are going for the static partition, you should be very sure that what you are going to load and where you are going to load. You should be good about the data understanding. Otherwise, if you will be loading the wrong, it will take the wrong. It is not going to notify you that hey, you are doing wrong. So this is a kind of manual thing which you have to take care, and this is useful only when you have good amount of data and you are well prepared with the data, you know about data and all, and you want to go with some selected data only. Let's say you are having 10 years of data, and out of 10 years you want to go for 1 year's October to January, sorry, October to December month only, or maybe some selective 6 month, or from last 2 years, only 2 to 4 months data kind of that. In that case, you want to avoid the entire data set. So you can go for the selective data, you can create the partition and you can load that. But this is the partition type which is used broadly, because here we are good. Whenever you are getting the good amount of data from the source, and you want to segregate the data dynamically to your table, and you do not want any manual action to do here, then we go for the dynamic. You have to simply enable the dynamic by doing the set CLI command I had shared in the last session, that you will be getting in the documentation as well. Just you have to enable that dynamic partition, and then as soon as you will be loading the data either from the table or loading from the file, automatically it will be scanning the data internally and it will be finding out, okay, let's say you are saying partition by year, then it will be scanning your data, how many years data is present into the file or present into the source table, and according to that it will be creating by default that many numbers of folders in the backend HDFS directory, and your data will be segregated accordingly, and there will not be any kind of error or mistakes that Hive did the wrong thing and 2024 data has been loaded into 2023. It will not be happen. It will be doing completely okay, but only condition is here you do not have any uh, control over the partition. If there is single record for the year, then for the single record only it will be creating a folder. If you have multiple records, too much data, then that is good, but it creates some issue if you have very less amount of data. Let's say you have 10 years data and each year's data is having one record, two record, 10 record, like that. Then for a small piece of data it will be creating separate folder and separate file internally in the HDFS. That may create a small file issue that you have to take care. Otherwise, if you have good amount of data, then dynamic partition is good. Today we are going to discuss about bucketing. So I believe that no one has questions up to partition. Niharika is new and Alpha is also new here. Uh, so they may have otherwise Chandan, Naresh, Pawan and all. You have any question?
No, no, no.
No.
Okay, fine then. Then here in the bucketing part, first of all, what is bucketing? So partitioning also we are doing for optimization only. Means you have 1 TB of data. If you are doing the bucket partition, your data is getting segregated with different folder, different partitions, and you are good to query the data. Now bucketing is also optimization only, which will be again doing the data distribution either with partition or without partition. Means you can apply bucketing with partitions also on top of partitions, or without partitions also you can go with the bucketing. The difference between in partition, as I said, that you do not have control. Let's say you have a data, this is one person, Ram, and this is Sam. Okay, and again let's say uh, Mohit and Amit, some names are there. This people belong to 2023, and this belong to again 2023, and this one through 2024, and this is to 2025. If you are going for the dynamic partition, if you are going for dynamic partition, then what will happen in HDFS? This is your HDFS path. Inside the HDFS, you will be getting year equal to 2023. Okay, and again you will be getting 2024 1, and one you will be getting 2025. Okay, here inside this you will be getting the file. One of the file will be loaded, let's say this one, and inside this how many record you will be having? You will be having 2 records, because 2 data belongs to 2023. For 24 you will be getting file with single record. Okay, this will be 0, not 1. And here you will be getting file with 1 record. 1 record only, and here also it will be same. Let me copy that. Here also you will be getting one record. So data will be segregated automatically based upon the year because you are doing partition by year. Now you do not have control over the data. Here for one record itself, it created one folder. For one record, it created one folder. And here also for one record, it created one folder. Here this is very small data, so you do not need that. If that is a good amount of data, then that is fine. In some of the condition, there can be a situation where for few years there is lots of data and for few years too small data. Like if we see the, let's say you are working for the YouTube analytics, YouTube data. Now you compare the data by 2017 to till now this year. Then you will be getting good amount of data. Now you do the analysis from 2010 to 16 or 17. Then you see how many videos and other activities are happening this time. This was not the same count in the previous years. Data will be comparatively too low if you are comparing to this time. In that condition, what will happen? Let's say for 2025, if you are working for that kind of any of the application you can take. Let's say you are getting 1 million videos every day. Even I am taking less count, this will be more than that. 1 million videos every day. And if you go to 2016 or 2016, then you are getting that 2016, 17, or you can say 2010 to 16. The entire is 10 million. Let's assume I am not talking about the exact volume. Let's say this was the total 10 million, and here every day you are getting 10 million. Then there is the differences, right? Then what you can plan? You can plan for a single directory where you can load the entire data 10 to 16, 10 to 16. Okay, and for the remaining, wherever good amount of data is, you can plan for the separate folder. Again, it completely depends upon the requirement, completely depends upon the business needs, and accordingly we can take the decision. But I wanted to say that here you do not have control until unless you are taking some manual you are doing some manual intervention and all. And if you want that, uh, you have the option bucketing where you can decide how many bucket you really need. Because here if you have today 3 years data, automatically it created 3 directory. If you will be having 1 more year data, automatically it will be creating one more. So this will be going by default. Bucketing means whenever you are creating the table, you can decide how many buckets really you need. If you are saying bucket 1, then entire data will be coming into the single folder. If you are saying bucket 3, entire data will be going to that number of buckets. And you can apply buckets on top of partitions also. There also it will be helping. Let's say for 2023 you have 10 million records. For 10 million records you think that it could be better if I can segregate again one more time. Then you can go for the bucketing. Bucketing will be storing the data into that many parts, and again data get is stored with the hashing logic, hashing indexing, and that will be enabling it to working in a faster manner, either for processing or data sampling or joining. It will be providing one more layer of optimization, and that will be helping you to get faster processing. So bucketing in Hive is a technique, optimization technique you can say, used to optimize the performance of the data queries by dividing the data in a table into more manageable parts. Okay, and uh, each bucket is a file in the table directory, and rows are assigned to a bucket based upon the hash of a specific column. Whatever column you are giving providing for the bucket while creating the table, based upon that column, it will be creating the hash and data will be distributed accordingly. It it uses hashing logic, hashing, where rows are assigned to buckets based upon the hash value of the bucketed columns. For example, you are having the data where you have user ID. Based upon the user ID, you wanted to distribute the data. Then it will be creating hash user ID, and means it will be creating n buckets, and n number of buckets will be getting the data based upon the hash ID for the user ID. Then Bucketing improves query performance by enabling efficient data reads and joins. Both in join also, if you are going to join, and if your table is having a bucketing, then your joining will be also faster. And it uh, uh, it improves uh, query performance for the reading and joining both, and it allow Hive to skip scanning unnecessary bucket. If you have 4, 5, 10 buckets and you want to do the data sampling, you want to scan some piece of data, then it will be avoiding all the buckets to scan unnecessarily. And we can do it with partition or without partition. So bucketing can be combined with partitioning to the further structure the for the data and improve performance. And the number of buckets is fixed when the table is created and cannot be altered later. That is a drawback, you can say. In partitioning, once your table is created and on top of that, additionally, you want to create the partition, number of partition, you have alter command. Using alter command, you can say alter table name, add partition equal to. You can add the partition. But here in bucketing, you can't add the number of bucket. Let's say you created table with 3 bucket. Now you are planning to have 4 bucket. You have to recreate the table, but you can't alter. So that's one thing. So number of bucket is fixed and table whenever table is getting created, we are providing the number and we can't alter. We have to recreate the table. And it is supported by tables. Then only manage tables in Hive can use the bucketing. Even you can try for external tables as well. And we have options clustered by to create the table, this bucketing table. Okay, so let's do this. Here I will go through this document. You can see here. This is bucketing in Hive where I have mentioned bucketing in Hive helps to organize data into more manageable chunks, distributing rows into a fixed number of buckets. Okay, based upon the value of a column or the column. Then steps we are going to do. First we will create the bucket table. Then we will load the data and then we will verify. So let's go with this data and creating the table. Okay. So here, this is the data, just sample data I have taken. And this is the table syntax we are going to create. You can also follow the same. So here, here I have already opened my Hive is running. It seems all is red. Okay. Let me see that if this is running fine. So database. Okay, it is working fine. Later I will restart my cluster. So here okay, here you can see one learning database is there, but there is no table. I have deleted all the previous tables. Okay, so we'll do use learning and nothing. There is no table. We need to create the table. Parallelly, I will go with the HDFS one. We'll see if data is there. So I had created one sample data here as well. Okay. Here we'll go through this. I have created one learning directory, this one. And let me do cd learning. And ll. I have a file employee data.csv. Let me do cat employee data CSV. This is the data I have just created. Okay. Where this is the employee ID, employee name, department, and hire date. For this, we are going to create the table. So let me create it. We can do create table. Create table name. So let's say employee bucket. Employee bucket table, and we can say ID, data type int, and name, data type string, or department, data type again string we can say, and hire date, when employee was hired. So hire date, let's say string. Even you can take date based upon the data value. And now I am taking clustered by. I am not taking partition as of now. We will see the exercise with partition also, that on top of the partition we can create the bucket table. Uh, then clustered by. In partition we had key partitioned by, right? Here we had something like partition by, and you are going to give something like whatever column you are following. But here we are going with the clustered by. Clustered by, and which column you are taking for clustering. So in partition and bucketing means based upon the ID key, based upon that you want to hash and you want to distribute the data. So better if you can provide this kind of column like ID and or some related column. Based upon that data can create its hash ID, and then it can distribute, it can divide the data, divide the data between the number of bucketing. And for partitioning, column value is different. Let's say you want to partition the data based upon the location, based upon the year, based upon the country, or maybe something else. So accordingly, column will be changed. So mostly in this case, if you would have gone to partition, then this can be the partition value, and this can be the bucketing value. So here, let's say cluster by uh, ID. Based upon ID, we will divide the data and into 3 buckets. How many bucket you need? Here you have to decide about the number. That many numbers will be created in backend, and you can't change it. As I said, you have to recreate the table if you want the number to be changed. So into, let's say, 3 buckets. Into 3 buckets, and then you can take the row delimiter, your data delimiter, whatever data is. So let's take row delimiter, row format, delimited fields, terminated by, it was CSV data, comma separated. So I will take this comma separator and let's create it. It's done. Now this table gets created. Now we'll take the uh, another. I will create one staging table also without any bucketing or partitioning. Using that I can load the data in the bucket table. Even we can load through file also, but I will go with the staging table. So let me do it. Create a staging table, employee staging. Employee, let's say staging, and then the entire columns. And then I will remove this bucketing because this is not a bucket table. This is a normal table, simple table. Row format, delimited fields, terminated by this one. It written. Now in this table, I will load the data, and then that data we can do the insert. So we'll load the data into this staging table, load data, I will load from local itself. In my local, I had not moved this data to HDFS path. Locally only I will be loading. So let me do pwd. This is my path and copy and then employee data dot csv. I will copy this entire path and we'll go to this Hive. Load data, local in path, and then need to give this path. Okay, and then into table name was employee staging. Employee staging, that's it. Now it will load the data, and from this staging table we can load into our main table. So let's query this data quickly. Select the star from employee staging. And we are good with the data. Okay. Now we are looking for bucketing. So for bucketing, again, like partition, we had some setup, our CLI command for bucketing also. We have one CLI command set hive enforce dot bucketing equal to true. Okay. Now I can insert override, either insert override or insert the table. I believe that you know the differences between insert and insert override. Override will just override the data. It will delete all the previous data, previously loaded data. Then let's say insert override. Anyways, we do not have the data, but I am writing this. Insert override table, and table name is employee bucketed. Employee bucketed, and then select ID, name, department, and then hire date, from employee staging. Employee staging. Okay. And let's say I want to do sorting. This is optional. Sort by ID. I am loading like this. Let's do it. Here you can see total job equal to 2. Launching jobs 1 out of 2. You can monitor this job if you want. You can take this query ID, and then using that you can monitor over this tracking URL. Okay. And to this tracking URL, you can see how this is functioning internally. And here it is giving some ideas as well that in order to change the average load for a reducer, do this setup set hive exec reducers bytes per reducer, means per reducer how much byte you want to take care. Then in order to limit the maximum number of reducer, by default it will be launching the reducer according to the data, according to the logic we have applied. But if you want to set the maximum limit, then you can apply this in order to set a constant number of reducer. So these things are just a hint from the job. If you want, you can do that. And that will be again a part of your optimization. It will be helping you. Okay. Then I guess something wrong. Return code to my previous job. Let me see what happened. Bucketed. There is no data. Loaded the data and map partition 0 error during job obtaining debugging performance execution error. Return code 2. Map produce tasks. Map produce job launch. Read write 0. Something happened wrong. Let me try one more time. Otherwise, maybe it can be the reason here everything looks red with the cluster. I need to restart that. That can be one of the issue. Again, this is coming with same.
Amika, can you try again without override keyword?
Okay. Even I will remove this sorting as well. This is also not needed. We have very limited data. Now insert into table. Insert into table. Just give me 1 minute. Still it has error, right? Let me restart this one very quickly. Okay, this will take maybe 2-3 minutes. In the meantime, anyone has anything to discuss? Any question? Any point?
Namika, last session you told me about this LDFC command. We can run it through Apache as well, right?
Huh?
So can you provide the steps? How can I set up, do the setup for that?
You are talking about Hadoop setup in local?
Yeah, because when I run the Hadoop command, through this, so it is taking time.
Okay.
Every single
Yeah, I will
query
share
is
that.
taking 2-3 minutes.
Okay, okay. I will share that. You have my mobile number, right?
Yeah, yeah.
Just ping me that. Otherwise, I will. Maybe I can
Okay,
forget.
yes. Thanks.
Okay. So in the meantime, we'll go through this document. Let that start. Here you can see this exercise. You can follow the same. Okay. Like here, you can take the data, any sample data, creating this table. this bucket table. Then I created this staging table for loading the data, whatever you have, and then this data we can insert into either our bucket table or partitioning table, wherever you want. Then we have once this load is done, then we can verify our data in HDFS path, where we will be getting like this. Let's say you have created the table, then this is your table name. Table name will be uh, folder name, right? Here I have did the with the default DB, that's why I do not see the database name. If I am doing with this any database, then here before table name you will be getting database name dot db, then your table name. So your folder database name is also a folder in the HDFS path, your table name also a folder, and after that you will be getting the files will be like this. So this is bucketed this is 0, then 1 2, and accordingly it will be getting divided. So each file represents a bucket, and data will be distributed across these files based upon the id column, whatever column you have given during table creation, like clustered by id. Then you can verify the you can verify this bucketing with query. You can run select command, select statement. And here I have mentioned for partition table with bucket, like you can do separate partition, you can do separate bucket, and then you can do partition table with bucket. And if you are applying both of the things in the single table, then your optimization will be more better than the single one. Here what you have to do, you have to create a partition table and bucket table, means the same table, enabling dynamic partition and bucketing. Here I applied a set command, set hive enforce bucketing equal to true. Like that, for partitioning you have set CLI command, and you have to apply that. So two line syntax for dynamic and one line for bucketing, and then loading the data into the staging table, and then verify. For that, what you have to do is, let's assume the same is your sample data. Then creating a table partition and bucketing, where first you are applying partitioning by year, and then clustered by ID. So you are applying partition also, you are applying bucketing also. Once that is done, then here setting wise you have to apply all three. First two is for partitioning, and this third one is for bucketing. Once that is done, then this is the staging table, just I created and loaded the data. And after that, you are loading the data into the uh, staging table. And once it is done, then you are inserting into your partitioning and bucketing table, which is uh, which is having partitioning and bucketing both. Now, if you are verifying this internally, then how it looks like. Now it will looks like this. This is the table name, employee part bucket. Okay. And after that, year equal to 2023. This is your partition column. And after the partition column, this is the bucket data. So first it will be having partitioning. And after partitioning, there will be bucketing with n number of bucket, whatever bucket you have given. So what you gave here, you gave bucket, how many bucket we had given? Cluster by, okay, clustered by into 3 buckets. So here you can see for year equal to 2023, there could be only one file if it is only partition. But as you said, bucket as also, and you have given clustered by 3 bucket into 3 buckets. Then it will be creating 3 files, 1 2 and 0 1 2 3. Okay, so this is going to divide the data accordingly. So like that you can do partitioning with bucketing. And this query will show the how many buckets in the sense in HDFS, that will be file. Each row is stored in and helping to verify the partitioning and bucketing that are working correctly. And this help in efficient partition and bucketing in Hive tables, improving query performance and data management both. Here is the point, differences between both. So this partitioning is a way of dividing the tables into the smaller, more manageable parts based upon the value of one or more columns, and each partition corresponds to a unique value of the partition column. Let's say you are saying year partitioned by year, then how many years are there? That many folders will be uniquely created. For the bucketing is a way to divide the data into fixed size based upon the value of one or more column, how many columns you have given during table creation. And each bucket is a file that contains a subset of the data. Then use case wise, this partitioning is useful when we have large data sets that can be naturally divided into the distinct groups, because manually you can, but it will be a kind of a hectic work, you can say. Let's say you have data with the 10 years, and each year's having 12 months, and 12 months is having 30, 31 or 28 days. And accordingly, if you have to do the data based upon the month or day, then you think manually how many folders you have to create. Maybe you can do some mistakes, you can miss someone, then you have to validate and verify. Again, you have to rework. So if we can avoid that kind of thing, so it will be creating automatically that many number of folders in backend, and naturally it will divide the data in the distinct groups according to that scanning data scan. Internally it will be doing that. And commonly this is used for time series data like partition by date, partition by year and all, and categorical data like country or department. Here, for the bucketing, this is useful when we need to perform operations like joins, aggregations, and large data sets. This helps in evenly distributing the data across the files to improve query performance. So this is having some other level of things, like it is doing the sorting also. It is dividing the data based upon the hashing. So it helps with good processing speed for the joining and aggregation if you have large amount of data. Then if we talk about the data organization, then in partition, data is stored into the separate directories on HDFS for each of the partition. And here in bucketing, data is divided into a fixed number of bucket, whatever number you have given while creating the table. Okay. We jump to another document. We were here. For this bucketing, data is divided into fixed number of buckets, and each bucket is stored as a file within the partition directory. If that is the partition table, if only bucket table, then it will be without bucket itself. And for example, a table bucketed by ID into 3 buckets will have 3 files in each partition directory. Performance wise, query the filter and partition column can significantly reduce the amount of data scanned, improving the performance. And here is one of the thing where excessive partitioning can lead to many small files, which can degrade the performance. As I said, maybe you can have some partition column where data is too low, means it is kind of uh, you were expecting like thousand and some 10,000 records, and maybe for few of the partitions you were getting minimal rows like 1, 10, 100 and all. So that can result into a small files issue, and that will degrade the performance. In bucketing can improve the performance by query that involve joins and aggregations on the bucketed column and all. And again, this will not be having the small file issues and all, because you are giving a good number of bucket, whatever you were expecting. Here also that can be, let's say you are saying a number of bucket and data is not according to that, input data is not, then of course this is also going to degrade, but chances will be less comparing to partitioning. Okay. So this is the thing. Now let me check if that is done. And it's done now. Let's see this again. I will close Hive first. We'll go again. So databases and huge learning. This is done. Tables may have created tables. So two tables are created. One is bucketed, one is staging. And before inserting the data, I need to set this command, set Hive. This is just session oriented. So if a session is done over, then this setting is also gone. So enforce dot bucketing. This is by default false. I need to do bucketing equal to true. Let's see if this time this is running fine or what. I will just copy this insert and I will paste. This is map produce accepted. It seems this will work this time. And here, if you go to this is the place where you can go through your logs and all. You can check it. Okay, here the status is still accepted, and you have this node. This is the node information. Here you can go through the logs. Here you can see all the status, how many jobs are running, which are failed, which are running, and all. If I go to the field, anyways, I had restarted. So I will not have any detail. Okay, so this is still running. Here you can see it has launched a number of mapper 1, reducer is 3. So then first mapper will be completed, then reducer will be completed. It's done. Okay, here you can see stage map page 1 reduce is 3, and then uh, this is the read and write. Read was this and write is this one. Now let me do select the start from. Okay, data is loaded here. Now go to the backend and see how data is distributed, means how data has been segregated with the number of buckets. So let me do so create table. So create table employee dynamic. Employee, sorry, this is wrong. This was bucketed. This is bucket table. So this is the table directory. I will copy this. Here the table is created. Now let's go to this HDFS and we'll verify here. HDFS DFS-ls. Go to this. So by default, we're expecting 3 parts because our cluster by 3 we had provided. So we can see here, this is having 3 created by default, and data is divided into this underscore 0, 1, and 2. These are the buckets. If you will go to the file, maybe we have very less files, right? I guess 4 or 5 records I had created. So 5 records is divided amongst them. Even we'll verify for 1. This is good if we have good amount of data. This is small amount is data for testing. It is okay. But for performance and all, if you want to say, we should have minimum some MB's data, if not GB. Then take bucketed 1, 2, 3, 4, 5, 6 underscore 0. So here you can see this is a database name. Database name is a folder now. Okay, learning.db, and your table name is also folder now, table bucketed, and then this is the file we have loaded. See, in this bucket, only one record is there, 3 Kavita HR and the hire date. If you will go through the another one, then it will be having, let's say 1. So then it will be having, if it is having only 1, then maybe remaining 2 is having 2 records. As we have total 5 records. So data has been divided. Now we'll see one exercise with the partitioning with bucketing. And then let me create the table here. Here you can see you have 2 records. Accordingly, data will be available in the third one also. Let me go to this document and we'll see partitioning with bucketing. So this is the table name where we have to create partitioning with bucketing. And then this is the staging table, and then you can do insert override and we can verify the data. So let me create this one. We'll create a table. Okay, then create table creation. We have to perform create table name. Table name, let's say employee partition and plus bucket, and then we can do ID, let's say int, and name, let's say this is string, then department, let's say this is also string, and then hire date, when employee was hired. So this is hire date. Let's say I am assigning this one also as a string. Then we'll go for the partition. Partitioned by, I want to partition by year. I do not have year column. We'll be creating that. Means based upon the data itself. Partition by year. And year also string. And then clustered by, or the bucketing. We are creating partitioning also. We are creating bucketing also. So clustered by, let's say I'm giving 2 only. I have very less amount of data. We'll do 2. Clustered by ID column, and then into 2 buckets. Into 2 buckets, and then row format delimited fields terminated by my comma separator. Then it's done. But it's wrong. Create table name, then column names, then partition by, clustered by ID into 2 buckets. Do you see anywhere I made wrong?
No,
Sorry.
no, nothing.
Create table name, that is fine. Name string, this is the one. Then partitioned by here. Then clustered by ID. This is also fine. Into 2 buckets. Then row format delimited fields terminated by, I do not see, clustered. Okay.
No, comma is required.
No, not required. We'll check it.
Pipeline.
The clusters fail.
No. Always it can't. Let me check it. So here I have to give this syntax, partitioned by this one, clustered by this column into 2 buckets. The syntax looks good only. I'm not getting where the issue is. Create table name, then all the columns, then partitioned by, and within bracket the column name, that is also fine. Then clustered by, spelling is CLUSTE. Okay, spelling is mistake. Here is the problem. CLUSTE. TERED, clustered by. Small mistakes will kill you. Okay, clustered by. Now this is created, and now after staging table already we have from where we can load the data. And if I go for the data, let me do select the star from employee staging. How many partitions we have? 1, 2. If I will do by date, then it should be all are distinct only, right? So those many partitions will get created. Okay, if
In
I
this,
want, I can have one more time. I will load one more time this same data. There will be duplicate, or maybe let me create this data one more time. I have LL
here we
employed.
don't have ER column.
No issue. We will create while loading. Just upon the headed, you can create some columns, manipulation, right? We can create the new columns like that. And I will load some more data. So let me do this. Let me create one more file. Vi emp data underscore one.csv. And in this, I will go with six indexing. And let's take Mohit again. And this guy depends to HR. And let's say I will give the same date 0501. Sorry, 2025 format is different. 2025, then 01 and then 05. This is the date. Let's say for 7th one. Let's say this is Priya. And for this girl, let me take it IT department. And her joining date is 2024 8 and 2nd. And let's take one more 8. And this is Smith. And this guy belongs to finance. And then let's give the higher date 2025 and again Jan and 5th. Let me take one more record. Why I am giving column comma separator? This is not required. And then 9th one. For 9th, let me take one more name. And then again IT. And this belongs to this date 2024 again 04 sorry 2024 and then 01 and then 04. Now I will be having the same date and all. Let's load. Let me load this data. We'll do pwd. This is the path. Then load data. Local in path and this is the path. Employee data 1 dot csv. File name was dot csv, right? Dot csv, yes. Into table employee staging. Loaded. Now let me do it. Run the same. Select start from. It is having more records now. Now you can see if we will be doing partitioning by year. Then for 24, I will be having 1, 2, 3, 4, 5, 6 records. For 25, 1, 2, 3. Accordingly, data will be divided. I will be having 2 partition. Okay, now let's load the data into this partitioning and bucketing table. For that, we need to enable this command required for partitioning and bucketing. Let's do set hive CLI hive dot check dot dynamic dot partition equal to true and then set Hive exec dynamic partition dot mode equal to non-strict, and for bucketing we have to do set Hive dot enforce dot bucketing equal to true. This 3 setup is done. Now we can load the data. For loading, we have to do insert. Here we had insert statement, right? Insert into table, employee, part, and then bucket. And then bucket, partition year. We have given partition by year. And then select ID, name, department, hire date. Then for year also we need some data. So let's do substring and we can take it based upon hire date. Hire date we need from 1 to 4. This is 4-digit, right? 2025 1 to 4 as year. And then from employee staging, let me do sorting, sort by ID. Where is wrong? Employee part bucket. This is not available. So tables. Employee, okay, EMP. So now this will be having this year column as partition, and then bucketing. We have given 2 buckets. So that means inside each partition, there will be 2 data file for each for the bucketing. If we have no bucket, then for each partition there will be single file based upon the block size. If data is exceeding block size, then there will be more than 1 file. So let it loaded and then we can move next. Anyone has any question or any doubt here? If so, please ask me. If I am faster, please stop me. No one has anything. That's great. What about you, Kasis? All good?
Hello, Namikas. Most probably, so I have worked with partitioning and bucketing before, so kind
So
of.
you're comfortable.
Yeah, yeah.
Okay, fine then. So
But
let's get it
only,
done quickly.
not a question, just
Yes, yes.
analysis. Suppose I'm currently working in BigQuery.
Huh?
Uh,
Google BigQuery.
yes, so
Okay.
there is two types of basically partitioning is there. Partitioning is almost used in all the projects because
Yes.
suppose we are doing a monthly report
Partitioning will be everywhere.
everywhere. Yeah.
Yeah.
But apart from that, clustering is a concept. Bucketing is not there. Clustering is something. Suppose if you are suppose this is a monthly reporting there, but it's not a you have done a partition on a monthly reporting, but you are not doing a full scan for that month. So that's why you have to sort the data. In that case, we use clustering. So it's kind of a more granularity level of or basically optimization. Basically, it
Right.
will not. It will basically once partition the data again. It will sort the data. So is there any similar concept available in Hive, or is bucketing
This
is a
is
different concept?
similar only.
Similar only. Okay.
Yes. Like say, let's say in Hive we have this map side join while we talk about optimization, right?
Yes.
When Spark came in the market, they adopted map produce only. It was the next and refined version of map produce Spark. Means whatever issue we had in the map produce that overcome with that. So map side join, they also have map side join, but they have named it as broadcasting. We are
Okay.
broadcasting the data, but what you are broadcasting, you are broadcasting the smaller data. If you have a small size of data, you are making a copy to each of the available nodes, and then data is getting joined from the same node, so data shuffling is avoided. You are restricting the data shuffle. Same concept is in Hive. We have map side join, where if you are enabling the map side join, then it will be making the copy of the small table, small data set, making available to each of the node, and without data movement, without data shuffle, your join will happen. So same concept they have taken, they have renamed it. So like that it will be with another services. In Azure also you have Athena and all. In Athena, if you are going, you have the exactly same Hive enabled tables. You can go with that, and whatever you are creating with Hive, similar syntax, 100% I can say you can just copy paste and that will be working. You can create with the partitioning and all by delimiters table. Like here we are going with the file formats and all, right? There
Yeah.
also you have to
So
define what is a
basically,
file
all the
format.
data arrays like, under an architecture is kind of same. Little bit syntax wise.
Architecture initially Hadoop came in the market, right? And it
Yes.
was worked for data distribution and all. Later on, different services came with their own services, like platforms, Amazon, AWS, Google, and many more. So they are trying to adapt they are trying to provide their own solution, that I am giving the better solution and bin solution, you can use that. But from where they have adapted the internal architecture, that's Hadoop only, I can say, base level. I am not saying that they are similar to Hadoop because they have their own enhancement, own services, maybe something better than this, right? Some advanced technologies and all. But base concept is taken from here.
So I think Hadoop was kind of a started at Google only, some Google file system or
Correct.
something.
Google File System, yes.
So yeah, even Google Cloud Storage is also this cloud service is similar to that only.
Correct,
So anyways,
correct.
that folder concept will be there. Yeah.
So that's what I'm saying. This was the beginner in the market, and this was started for the data engineering side to deal with the huge amount of data. Then people faced the issue because here we have um, pre-set up cluster, right? If you are looking for 10 node cluster or 20 node cluster in advance, you have to do the investment. And let's say you did the investment for 50 node cluster and your project did not work well. You are going to shut down the project. Then what about your investment? You lose your amount, right? You can't
Yes.
recover that. If you are
Yes.
selling, that will be second hand and third hand. So in that case, cloud services are helping you because that is on demand. If you are looking for two node, just go with two node. Tomorrow your data is getting increased, you increase your cluster with two more nodes, four more nodes. So anytime you can remove the means you can remove the cluster, you can delete, you can add the nodes, you can remove the nodes. That is flexible as per your requirement. So you are not thinking about more admin part, cluster setup part and all. You are focusing on development side, your project work. So remaining part, your platform side of the work, they are taking care. Okay, I am taking care for the nodes and all. You just focus on your coding, focus on the development. So that's why they are helping. But basic concept is same. Okay, so
Yes.
the data has been loaded. Let me check the partitions here. How many partitions are created? So I will run so partitions. So partitions, employee, part, and bucket. What is wrong? I did something wrong.
Syntax error maybe.
Hmm. partitions. So total 2 partitions has been created, 24 and 25. These 2 folders we can see in the backend. Let me do show create table so we can verify quickly its location, how data has been segregated. So create table, this table name. Okay, so this is the location detail. Let me copy and then we'll go to HDFS. Hadoop fs -ls and this one. So this one you can see year equal to 2024, 2025. 2 partitions has been created as a separate folder. Now we'll go to that level as well, year equal to 2024. And then it will be having the details for the files. There will be, okay, we have created 2 bucket. So accordingly it should be. Yeah, for 2 bucket, there is 0 and 0, 1. So, okay. And if you go to the 5 here itself, here also it should have two files for the buckets. If you not enable this bucket, then there will be single file only, because this is a very small file size. So like this, you can apply bucketing on your table, you can apply partitioning on your table, and you can merge both. You can create the table with bucket and partitioning both all together. So you can enable one more level of optimization. That is the thing. Now let me go to the documentation, and here we did the verification. Now in the same document I have here I have given some details about the partitioning and bucketing, how it divides the data between both, like it is dividing the data based upon the column value, and this divides the data into fixed number of buckets we are providing. Accordingly, this will be creating the folders. Now you have Hive alter command. Let's say once you create the table and you want to make some changes, then you can. You can go through these commands like alter table, table name, set file format. If you want to set the file format after creating the table, or you want to change table row format, adding the new column, dropping the column which is already created, changing the column type. Let's say data type we created higher date equal to string, but I want now higher date equal to date or time stamp related some other column type I want to, data type I want to provide, then we can. Like here I have given alter table, table name, higher date. I am giving date, data type. Initially, I have created the table with string data type. So which you can change. Then renaming the column. If you want to rename the column, you can run this command. And then renaming the table. Let's say you want to rename table itself, then that is also okay. You can adding the partition. As of now, here if you go, I can see I have 2 partitions. I had run this query. Okay, let me go to this Hive session. So partitions, I have 2 partition. If I want to add one more partition, that also I can do. Manually, you can add the partition. So alter table, employee name, add partition, any partition name you can do, and this will be adding the partition. But that will be blank partition because you are adding on yourself, right? If a table has created the partition, that is based upon the data because it scanned the data internally, and according to the data it got the value, and based upon the value it created the partition. Our data had 2024 and 25 data, but let's say I have some manual data I want to load into some dummy partition, then I can create the dummy partition and I can load the data into that. That will be my manual work. Then dropping a partition. If you have some partition, let's say your table is having some 100 partitions, by default it has been created. You think that these are some older partitions and this data really you don't need, then let's drop the partition. You can drop that. Then change the table bucketing. As initially only I had said, you can't modify the bucket. Everything you can modify, alter. Bucketing, number of bucket you can't. So directly changing the number of bucket is not supported by alter command. What you have to do, you have to drop the table and you have to recreate the table. That is only one option. Then set or change the table properties. Table properties, when you go here to the Hive, you can see table, create table name. Here you can see some table properties, which is the by default one. Okay, so you can do some table properties on your own. If you want to do the setup. So here I have mentioned all one, everyone, what I discussed above. You can just run this command one by one and you can do the exercise. Then uh, different type of joins in Hive, including sample data. Here I have I have given the sample data and these joins. Before that, I will be telling you one use case. Maybe you were already aware or you are not aware. Let's say you are here. We had the data. Uh, Let me go to the HDFS and LL cat emp data, emp data.csv. Here I do not have header, right? What if you have header? Then it will be loading the header also in the table, and that will be issue for the table, because a header will be going as row number 1, and that is wrong. Let me edit this data. We'll do it quickly. Let me do vi employee data.csv, and I will modify it. I will make it here ID and then name, then department, and then hire date. Let me do it. Now my data is having now header also. Now if I will be loading the same data into the table, that header will be going with the row number 1, and that is wrong. Okay, let me create a table here, just normal table. Create table. I will remove this bucket and partition because I am going to create the normal one. Okay, create table and then employee test.
It will be showing as a null, right?
No, it will not be showing as a null. Let me show you. I will be loading the data. That's a very simple use case, and you may face issue in your real time if you are not taking care of it. Let me load this data, and now I will query the data. Select the star from employee test. What happened? There is no data. This loaded number of files 3. How come? Okay, sorry, I loaded into staging table. That's wrong. I have to load into employee test. Now run this. If you see this is coming as a row, row number 1, right? This is because of some maybe some spaces or something. It is coming as null. It should come fine. So
No,
this
because we ID column we have specified as a end, and in the
okay,
header it is showing string, right?
string.
That
Okay,
is
yeah,
right.
yeah. Based upon because of that, this is coming as null
Yes.
because data is changed. So this we have multiple regions to get null. Either you have some different delimiter or maybe different data type, that can be. So here we get this data as row number 1. You think that this is the good output what you were expecting? It should be no, right? In real time also, sometimes you get the input data that can have header, that is without header. It can be anything. So you have to always take care either that data is having the header or not. If yes, then you have to take care of that. So I need to remove this because this is not row number 1. If I do select count star from, select count star from table. it will be giving me 6 count, but exactly my data is having 5 counts and not 6. It is considering this column name also as a row count. So that is wrong. What can we do here? We have to create the table with table properties. Here we see the table properties we can set properties we can do. Here we have to provide skip row. How many row you want to skip during table creation, during loading the data, then it will be taking care of that. Let me search here if I have mentioned skip header. I guess that is not there. Let me check that. If I have not mentioned, then I will mention that. Should be somewhere in the document. I remember that I had mentioned escape dot header. It seems it is not. Okay, I will check it. So let me go here. I will drop the table and I will recreate by table properties. Even we can alter that, but I will do that. Okay, it is taking lots of time just for doing the count. I will kill it. Let me go to Hive again. This is skip. I have mentioned either in this document or maybe in this. Okay, I will check if any out of this both I have mentioned or not. Otherwise, I will modify this document. We were here, right? Join. So quickly, I will recreate the table, then we will go through that. Here, if you see in the same document, I have mentioned some practice session as well, where you can go through. You can just repeat it. Repeat this. This will be working fine. It is done. Okay, it is still loading. Okay, it is done. Now I will go with huge learning. And then I will drop the table. So tables. So tables. I have this test table. I will drop it. Drop table. Drop imply test. Drop table. prop table imply test. I will recreate it. So here I had the create statement. I will take the same. This one, right? Row format delimited fields, and then have to give this skip header. So for that you have to give table properties, tbl properties, table properties, and here in bracket we have to define skip how many lines you want to skip. You can say that skip dot header dot line dot count equal to 1. Here I have only 1, but if you want many records to skip, you can say that. So let's say 1. Now do this, run this, and then we'll load the data. For loading the data, I had this command. Let me copy that. This syntax. Now let me query. Select the star from employee test. Now data is fine, right? So you have to take care in the real time that data is having a header or not. If you are having header, then you have to give this table properties. Otherwise, data will be loaded wrong. This is one thing. Now let's go to the join section. In Hive, it is supporting almost all the joins which you have in your SQL. If you are from SQL background, then that will be helping you, like left join, right join, full outer, and same anti-semi joins, anti-joins and all. So is this supports all the joins. Here I have mentioned some of the joins. You can go through it, go through this exercise and do this. Here you have inner join, what will be the input and what is the expected output, that also I have mentioned. If you are new with the SQL, then that will be helping you to understand. If you are already having experience, then that's good. It is good for you. Then left join, and then right join. After that full join, cross join, and then map join. So I believe that everyone is good with join. Am I correct or wrong?
Yes. For me,
What
I'm
about you? Okay. What about you, Om Prakash? Om Prakash is there? Okay, he left.
he left.
He's quite new.
Just a quick question, Anamika. Just
Mhm.
Hive is similar to other database, no? Almost.
Yes. That is
Only
designed in a way that if you are from SQL background, you can work very smoothly.
only part is how the architecture is little bit different because you use HDFS as a storage. That is the
It is
only
working
difference.
in the distributed model.
Yeah,
And this
got.
is not actually a database because this is not having any storage capacity.
That's
This
the
is
difference. Yeah.
maintaining only schema.
Okay. So there may be some control difference because they were using HDFS as a storage.
Correct.
It
For
should be. It
see,
should.
any data is having two parts. One is schema and one is data. So in Hive, you can only visualize the data, means just displaying the data as a warehouse. But the schema is getting maintained by default with Derby database, and in real time, Derby will be replaced with, let's say, MySQL. So MySQL will be maintaining the schema, and the data will be get maintained by the HDFS. So Hive has nothing, neither
But
schema
suppose
nor
when we are
data.
aggregating, firing a query which aggregates the data, then
Hmm.
how it, which engine it has its own query engine, or basically the compute
It has
where it takes.
MapReduce by default. It has Stage. Okay. It
Okay.
has a Spark. You can change the Spark in. You can run the. You can change the execution engine. And here, when you are firing the query, we already seen what is the engine by default running. That is MapReduce, right? You are
Absolutely.
saying mapper, mapper reducer, number of mapper. So by default, this is running with MapReduce. But
So
you
so
can change.
basically, it's basically just a layer we can where basically we can use the basically Spark job in a
Mhm.
manner that we can use SQL queries. So in backend it converts
Correct.
to a map reducer. Got it.
Correct. So if you are a non-programmer, if you are not good with coding, then also you can work with it. Like in Spark also, you have multiple things. Like you have a Spark SQL. So if you are good with the SQL background, then you can work directly with the Spark SQL. That will be
Yeah.
helping you.
Got it.
Okay. So all kind of joins you can apply here in Hive that will be working. Here is a map join. I was discussing about this, right? Map join when this is a kind of optimization. When you have a small data table and you have to join, then by default here what happens in Hadoop, by default map reduce job will be running. Mapper means working with the same partition. It will be just doing the kind of filtering and all map, flat map. And then aggregation, for the aggregation part, data shuffle will happen. Data will be moving from one node to another node. And sometimes that is unnecessary task. Unnecessary task in the sense, let's say you have 10 GB of one table with 10 GB data and one table with uh, 50 MB data only. You have to join both. For 50 MB data only, your all 10 GB data will be moving around, right? Because they need to communicate with that 50 MB data. They need to join. For joining, they need to communicate with each other. We can avoid that. You can enable map join, and once you enable map join, then your cluster will means you have yarn as a resource manager, right? So your resource manager will be creating a copy of that small data set. And if you are having 10 nodes where your bigger table has been uh, available, means that has been distributed, it is available there, it will be making a copy and enabling to each of the node. It will be available. In that case, that bigger table data will not moving around here and there, because at the same place wherever that is existing at the same node, if that got the small tables data available one copy, then why this will move around, right? At the same place this will be doing the join. So in that way we can avoid data shuffling, data movement unnecessarily. That will be a costly operation that is going to take lots of time. We can enable map join, that is for one small data set, one bigger data set, that will be helping around. Where we have query this query, and you have to say join department id on department id map join d. Here I have given the syntax and all how you can do. Like this is again with the you have map join, you can enable that. You have bucket map join. When you have map bucket table and on top of that table you are going with the bucket map join, then that will be more optimized, that will be more faster. Okay. Then you have semi join, you have anti join. So all the joins are here. And here map join, you can see here optimize join performance by loading a small table into the memory. It will be making the small table data completely into the memory, and that will be available for each of the node, and that will be helping. Here I have given details for map side join, how you can. So first you have to understand that map side join is an optimization techniques in Hive, where a smaller table is loaded into the memory and joined with a larger table. Okay. Here you have to make this, you have to run this. That will be helping you to enable map side join. It will understand that, okay, you are looking for map side join. Then a non-conditional task, you have to give, you can specify a size also, how much size you are looking for the distribution. And then if you are having, anyways, we are not going to work as admin, so we should not think about this. Hive hyphen site.xml property file, this will be because we will not have the access in the real time. But if you go and see the file, you will be getting the by default settings, whatever setting is. And if you want to change, if you have access, you can change directly. Or this is the better part for as a developer. At the runtime, we can do the setup whatever we want, and that will be for our particular job. Then by that way, you can enable map set join and you can work with that. Here I have given the syntax as well. Okay. And then you have here we have some setups like set Hive maps where map join small tables, file size equal to this, large tables equal to this, how much you are looking for. Then you have here I have mentioned one practice exercise. You just go with this. Here I have given input data also and out. This is two input. This is one input table where you have only mark column and expected output is marks. Then this is the output. This is the output one. This is having some window functions requirement. Okay. Anyone is aware about window functions or
Lead lag.
yes. So
Lag.
uh, here I have mentioned that exercise. If you can do the practice, here is the lag and lead lag row number over partition by. Suggest you can exercise that. And then data masking. Data masking in the sense, anyways, we can do this very perfectly with Python, with the Spark and all. But here as we are with Hive only, so let's do with the SQL command itself. If you have to mask the data where you do not want to show the real data, you want to hide the data, then you can apply the masking. Like you want get the output like this, XXX, then only visualize only the last 4 digit and hide the remaining digit. So like that you can do that. Okay. Then if you move to the same document, this is just exercise, you can follow that. Then we have views and indexing in Hive. View just like your SQL itself. In SQL, what we do, we have a table, and on top of the table, we create the view, we create the indexing. So view means just it will be storing the query for you, and you can run that. It will be updating the data, view data based upon the actual table data. That means a virtual table, right? I believe that everyone is aware about that. Is it, or anyone needs the additional explanation about this? What happened?
Yes, I know.
Okay, no issue. I will go through this. So view is a virtual table based upon the result set of a SQL query. Let's say you have a complex SQL query and you have to run that again and again. Then why not to save that query and get the data? That is only a kind of view where you can create combining with multiple tables or single table or with your simple syntax or complex syntax, whatever. Data will not stored physically. It will store only the query, and you will whenever you will be querying the view, then it will be refreshing the view always. That means it is working, it is going to work on the actual table, and if actual table data has been refreshed, then your view also will be getting the refreshed data. Why use a view in Hive? Because simplify complex query. When we have a complex query with multiple joins, segregations or filtering condition, then we can save that query as a view and we can avoid rewriting the query again and again, and we can just run it. Reusability, view allow us to create a logical structure for frequent users query, and we can query the view repeatedly instead of recreating the query each time. And then data security also. Data security is the main concern. Let's say you are working with a banking system. In banking system, you know how much data security requires. If you have a table with 20 columns, and let's say that table contains a user credential and credit card number, debit card number, some mobile number, critical mobile number where they are getting their OTP and all, and someone wants the access of the table, same table within your organization only, but they are not the authorized person to get all the uh, personal data like credit card, debit card numbers and all. Then what you can do, you are not looking for sharing all the data, you want to restrict them, then you can create a view and you can share them whatever actually they need. Like if you do not want to share all the column, then you can filter all those column in your view, and you can say okay, you select out of 10 you can select some 5 columns, you can create a view and you can share with them. Then they can query only the view and not the actual table, and whatever column you have not mentioned in the view, they will not be having access, they will not be good to query the data. So in banking systems and all, wherever data restriction is required, view will be in practice. And you will be seeing that for almost all the tables, there is a layer of view, which is for unauthorized users and team. They are just using that for their analysis, but they are not good to access the entire data, entire table, whatever we have. Okay, so for that condition, we go for the view. Okay, I will start the session today here itself. View and indexing, that is a small thing. Tomorrow, before starting with Python, I will go for 10-20 minutes with this, and then we will start with the Python. We will close the Hive. Okay. Anyone has any question, anything today for today's one, or maybe with the previous session? Any comment? No? Fine. Then let's meet tomorrow. Tomorrow I will cover this remaining part, view and indexing, and with some optimization steps. And then we will start with the Python. Okay. And for exercise wise, go through the same document. I have mentioned the exercise. You can do that. Okay, fine then. Let's meet tomorrow. Have a good day.
Thank you,
Bye.
Anamika.
Yeah. Okay.